Today we'll be solving 2870 lead code problems. Minimum number of operations to make an array empty. So you are given 0 indexed array nums consisting of positive integers. Okay. There are two type of operation that you can apply on the array any number of times. First operation is choose two elements with equal values and delete them from the array. Choose two elements with equal values. So basically 2 and 2 is equal, we can choose these two and then we can delete it. Okay, choose three elements with equal values and delete them from the array. So we can, if there are three elements, let's say 2 2 2, all three in one go we can delete it. Then return the minimum number of operations required to make the array empty. Okay, and if it is not possible to make array empty, it's -1. So here if we'll see, there is how many 2's, 1 2 3 4. So we cannot make in a first operation 3 2 and then there will be 1 2 will be left. So which is, because for 1 there is a no way we can delete it, either it has to be multiple of 2's or multiple of 3. So what we can do here, we'll remove these two first and then another 2 secondly, then we'll be left with 3 3 3. So the counter is 3, so we can remove it in one go. So basically we did till now 3 operations. In the first operation we removed 2 2's, in second operation we again removed 2 2's, in the third operation we removed all these 3's, and then we'll be left with these 2 4's. Then in the fourth operation we'll be removing these 2 4's. So that's why the output is 4. Okay, now I got the idea like how we can think of the solution of this. So yeah, let me write something for you. So what I can think of right now, any number I can represent in the form of multiple of 3. So it can be any number I can represent in the form of like 3k plus 1, 3k plus 2 or 3k, right? Why I'm choosing 3? Because we need to return the minimum operations. So basically always in a greedy approach, I'll try to remove all those basically in the group of 3's, not in group of 2's. Let's say if there are 6 elements of same values, if we'll remove it by 2 in a chunk of 2, it will take 3 operation. But if we'll remove it in the chunk of 3, it will take only 2 operations. Now the idea is around like any number I can represent in the form of 3k plus 1, 3k plus 2 or 3k. The reason, because if you divide any number, like any number and divide by 3, you will get either 3 remainders, 0 1 and 2. If it is 0, then it's like a complete multiple of 3's. If it is 1, then it will be 3k plus 1, and if it is 2, then it is 3k plus 2. Now if in that array, that input array, let's say if any element is of multiple of 3's, we can simply use its division counter. Let's say if it is 6, we can just say like 2 operation will be needed for at least that element. So basically let's do one thing. Let's count how many times 2 came here. 2 came here 4 times, 3 came here 3 times, 4 came here 2 times. So any number which will be of multiple of 3's, I can simply do it in a one operation. Basically if it will be 3, so it will be just multiple of 3's. So this is 3, so it will take one operation. It will be, if it will be 6, I would have taken 2 operation. If it would be 9, I would have taken the 3 operation. Basically the division value, I will be taking that as an operation. Now coming to other two thing, so for any element which is of 3k multiplus, the operation will be k operations. Okay, now coming to 3k plus 2, what we can do when the remainder is 2, it will be k plus 1 operation. How? So k will be consumed for 3k frequencies and 1 extra will be needed for 2. For example, 3k plus 2 kind of like 8. So we can write into 3 into 2, which is 6 plus 2. So how many operation? Like in a group of 3, in 2 operations we have removed the 6 elements, and the next operation we removed the 2 elements altogether, so it becomes the 3 operations. Now in the case of 3k plus 1, what we can do, so it's like here the remainder is 1. What if we will do like 3 into k minus 1. If we do 3 into k minus 1, we'll be left with 4 will be left with 4 frequencies, and that force can be done into in 2 operations. So overall how many operation it will be, I can show you that with example. K minus 1 plus 2 again, which is k plus 1. So example will be, let's say 7. So I can factor this 7 into 3 into let's say 3 into 2 is 6, and then we'll get the 1 as a remainder, but this time we'll take k minus 1. So 3 into 1, which becomes 3, and then we'll be left with 4, then 2 into 2. So how many total operation will be? 2 plus 1, which is 3 operations. So basically for all the multiple of 3's, we'll be having k operation. For all non-multiple of 3's, it will be just k plus 1. That's it. Okay. And there is one catch. If there will be any element with frequency of 1, in that case it's not possible to remove, because we need to remove it in the group of 2 or 3. So in that case we'll return minus 1. Okay, so let's code it out. So in the collection library we have counter. We'll create a counter out of this nums, and now we'll be iterating on to basically it gives like key comma. We don't need key at all, we just need item in d dot items. If item equals to minus 1, which we said like if it is equals to 1, if there is only one frequency of any particular element is present, then we can simply return minus 1 and we'll break it from here. Else, if item is perfectly multiple of 3, we'll just add into our resultant. We'll create one resultant variable here, keep it 0, then we'll just add it like item by 3, that k values are the the division factor basically. And if it is not mod of 3, we just know like what we need to do is it's a k plus 1. So basically item by 3, whatever the integer division value, plus 1. Okay, now I think we are done. So let's try this. Yeah, it's working. Let's submit it. Fine. So yeah, it's 539 millisecond, and yeah. So overall time complexity for this will be just what we did, like we just created a counter. So basically we iterated to each elements. So it's like time complexity will be O of n, and we are storing into dictionary. So at worst, this dictionary will be having every element of single frequency, which is again like space complexity will be of O of n again. That's the extra space we are using here, and space complexity will be this. Yeah, thank you everyone.